Hey guys, today we're going to take a look at some special motion problems. We'll lead off with some pulley problems. So pulley problems are when we have two masses that are connected on opposite sides of a pulley so that they're free to move. So let's take a look at this situation right here. We have a 3 kilogram mass on one side, a 5 kilogram mass on the other side. What would be the downward force of gravity on each mass? So, of course, it would just be, we'll call this M1, we'll call this M2. Well, Fg1, the force of gravity on the first one, would just be M times G, which would be 3 times negative 9.8, which is negative 29.4 newtons, right? And the second one, same deal, mg, but this time 5 times negative 9.8, and that's going to be negative 49 newtons. Okay? So what would be the net force acting to accelerate the system of masses? Well, basically what we have to do is we have to look at the difference, right? Obviously, the 5 kilogram mass would be pulling a little bit harder. How much harder? Well, it would be negative 49 minus negative 29.4. The net force going down is going to be 19.6 newtons. So what would be the acceleration on the whole system of the masses? Well, we know that F net equals the mass times the acceleration. We know that the net force is negative 19.6. We know the total mass is 8 kilograms. That's the sum of the masses of the sum of the masses. So we're solving for A. So what's negative 19.6 divided by 8? Well, it's negative 2.45 meters per second squared. Okay? Now, what about the tension on the left side? What about the tension on the left side? Tension is going to be bigger than the weight. This is reasonable because a string not only supports the mass, but it also pulls the mass in the opposite direction. So the tension is going to be a little bit more than the weight itself. Okay? So we know that the weight is 29.4, so it should be more than 29.4. So let's take a look at what it's going to be. We know that F net equals mass times acceleration. We know that F net is going to be tension plus mg. That's equal to ma. We don't know tension, but we know that the mass times g is going to be negative 29.4 because we already calculated that. We know that the overall mass, the mass on the left side rather, just only the mass on the left side is 3, but the acceleration of the whole system is going to be 2.45. And yeah, going back to here, the whole system, I guess, doesn't have a negative. Like it's okay if it's okay here if we consider these to be negative answers. That is, that it's a negative net force and a negative acceleration. But when we talk about the acceleration in a global sense, in the sense that the system is accelerating, it wouldn't necessarily be a negative acceleration. So we're going to keep that acceleration positive. Okay? We're going to keep that acceleration positive. And for that reason, we can actually just change this to a positive, and we're only really considering the difference between these two things, so we can even consider that to be a positive 19.6 as well. Okay, so we get 3 times 2.45, which is going to be 7.35. So to figure out what the tension is going to be, tension is going to be 7.35 plus 29.4. So that's going to be 36.75 newtons. That's the tension on the left side. Okay? Now, how about the tension on the right side? How about the tension on the right side? Now, the tension is less than the weight, so tension is not strong enough to support the mass, therefore the object falls. So in this case, what we have to consider is because the object is going down instead of up, the acceleration is negative now. The acceleration is going to be negative 2.45. So here, the acceleration was positive because the system was going up on the left side. Here, the acceleration is going to be negative because it's going down. So, we'll use the same formula. F net equals mass times acceleration. F net is the tension plus mg equals mass times acceleration. And we already know what that mg is because we calculated that at the very beginning. That is negative 49. So that's negative 49. We know that the mass is 5 and the acceleration is negative 2.45. So, we're going to get negative 12.25 plus 49, which is going to give us 36.75 newtons as the force of tension going down for mass 2. Okay? So because it's falling, its tension is not going to be as strong as the gravitational force. Let's look at motion on an inclined plane. In other words, we have an object on something that's sloped, and we're going to take a look at motion associated with it. Okay? So, when an object sits on an inclined plane, gravity acts to pull it down the plane. That's Fd. Gravity also acts to push it against the plane at 90 degrees to the first direction. That's Fp. So this is perpendicular. This is Fp. This suggests that we need to use components to find out what Fd and Fp are. From the triangle, we know that Fd is going to be mg times sine theta, where theta is this angle right here. Likewise, Fp is going to be mg times cos theta. Okay? So, let's do an example. A 4 kilogram object is on a 3 meter incline, as shown below. The angle is 17.5 degrees. find the force perpendicular to the plane. Okay? So that's going to be FP. That's going to be mg cos theta FP. So m is 4. That's negative 9.8. I guess we don't even really need negative. We can just put 9.8 times the cosine, 17.5. And that's going to be 37.4 newtons. Okay? How about the force down the plane? This is FD. That's mg sine theta. So FD is 4 times 9.8 times the sine of 17.5 degrees. FD is going to be 11.8 newtons. Now, what is the acceleration down the plane? Well, we know that FD, that's our net force going as the object's moving down the plane. That's going to equal the mass times acceleration. We know that's 11.8 newtons. We know the mass of the object is 4 kilograms. So solve for the acceleration. It's 11.8 over 4. And that's going to be 2.95 meters per second squared. Okay? Now, find the time to roll down the incline. So we're going to use a little bit of kinematics here. Okay? We know our initial velocity is 0. We want to find time. We know the acceleration is 2.95. We know the distance is 3 meters. So we're going to use D equals VIT plus 1/2 AT squared. So 3 equals 0T plus 1/2 2.95 T squared. So 3 equals half of 2.95 is 1.475 T squared. And if we take 3 and divide it by that, we're going to get we're going to get 2.0339 equals T squared. Take the square root of that, and we get 1.42 seconds. 1.42 seconds. Okay? Now, what's the velocity at the bottom? Well, we know the initial velocity is 0. We know the time is 1.42 seconds. We know the acceleration is 2.95 meters per second squared. We know the distance is 3 meters, and we want to find the final velocity. So we can use pretty much anything we want. Let's use acceleration equals VF minus VI over T. So that's 2.95 initial velocity is 0, so that's just going to be final velocity over time, which is 1.42. Final velocity is going to be 2.95 times 1.42, and that's 4.19 meters per second. Alright, so you've got some sample problems to try. Make sure to work through them as best as you can. You do have a work period on this, so use it wisely.